Okay, so everything's set up. Welcome everybody. My name is Kai. I'm working for Deutsche Telekom and would like to present you mainly the Eclipse SmartHome project. And actually my life is all around smart home. I'm the founder of the Open Hub project, Open Home Automation Bus. I'm the project lead of the Eclipse SmartHome project since a year now. And I'm working at Deutsche Telekom on a smart home platform called KiwiCon. So all smart home. I'm doing that day and night. Well, we're here at the IoT Day. Smart home is more or less a subset of the Internet of Things, I would say. But this subset has some very specific requirements and situations. So we've learned this morning, Benjamin, that an IoT solution usually requires some things, actuators, sensors, a gateway, some cloud service, and an end-user front end. A bit more abstract picture of that you see here. So it's a fairly easy pattern, and we all now know how to do it, and we all will do it. So if this is one IoT solution, then this is how many IoT solutions look like. That's all right for you as a company offering one solution and you're pretty happy it all works nicely and smoothly. But from perspective of the end customer for a smart home, who is really a consumer, an end consumer, not some company wanting to have some commercial solution built for themselves. And this is a bit of a nightmare here. Yeah? It looks a bit like a big thunderstorm over your house, and you see you end up with many different gateways here, and it's really a lot of infrastructure, a lot of dependencies that you as an end customer have, and this is really not a nice situation. So one thing which definitely makes sense here is to say, well, this gateway there at home, that doesn't have to be so many of them. It's enough if there's a single shared gateway, and this could be rather similar to like you have just one router at home to do the internet connection as well, right? So for all your Wi-Fi enabled devices, you have the router and that's enough. And such a home gateway for smart home solutions is more or less the same situation. And one day that could actually be merged into the router device itself. Now, the approach of Eclipse SmartHome here is really to not think of vertical IoT solutions, but rather to say, well, you have some platform here, and you have then others who are building the devices and adding services around that. So that's why this shared gateway makes sense here. Talking about the platform might also mean that the cloud part of all your services can be merged into some common infrastructure. And if you're really some hardware vendor who just want to now have a connected version of your product, you might not want to deal with the fact that you have to set up your own cloud infrastructure, having all the remote provisioning and everything doing that on your own, because that's really not your expertise at all. You're just concentrated on building the piece of hardware. And so having platforms available where you can simply hook in makes a lot of sense here. Now, do you actually know the difference between a connected home and a smart home? Well, this is how a connected home looks like, yeah, what I just described here. But to me, a smart home should rather look like that. It's a bit similar to if I claim I'm the smartest person here in the room because, well, I know how to Google the internet, right? So I can give you any answer you like. But what would I be without the phone, without the connectivity? It wouldn't make me a smart person, right? So it's fairly similar with a smart home to me. If you are just smart because you depend on something out there, This is not really smartness, but it's just, okay, connected, and you might get some additional value by that connectivity. So one big requirement for me for the smart home is really to have local intelligence, local connectivity, and not having a mandatory dependency on any cloud service. I'm not saying that cloud service shouldn't be there, but it should be some optional additional value. Now, that's why I'm also like to talk for Eclipse Smart Home around not the Internet of Things, but an intranet of things. So the devices that you buy as an end customer, they are local at home. You have them on your local area network. Why shouldn't they communicate locally, store their data locally, first of all? And Eclipse Smart Home is really a project which provides a framework to build such home gateways that allow the local communication and that allow to build solutions that integrate that all into one piece. And it doesn't say that, well, we try to establish a kind of new standard and we want that everything speaks CoAP or MQTT in 2 years' time. But we really accept that there is a large variety of different protocols and APIs, and that will stay for a long time. And yeah, so we're really trying to be an integration point here to simply make it possible to still interconnect these very different things with each other. Now, saying it's a platform or a framework, it's more or less based on Java OSGI, so it's a set of OSGI bundles that bring you some functionality, services, APIs, and based on such a framework, you can build then solutions on top. So the project OpenHub that I mentioned is one freely available open source solution which internally makes use of Eclipse Smart Home project. Our Deutsche Telekom solution KiwiCon, it's a solution that you can buy in the shops. It's a home gateway, real hardware that you buy. On this hardware you have the OSGI bundles of Eclipse Smart Home, and so this is also used internally. If I say services and APIs, what exactly is that? So in the very core there's a domain model specific for smart home, so typical things that you find there like blinds, heating, temperature values and so on. So it's really dedicated for the smart home use. Around that there's an eventing concept, so what kind of information, data do you get out of things, which is usually the stuff that you look at in IoT in general, but it's also the other side, what kind of commands and operations can you actually do to the things, which is an equally important part in the smart home. Based on these events, there are then 4 main functional categories of APIs. One is all around the connectivity, of course. There are first of all the so-called bindings, which are then the pluggable modules to connect to a certain specific protocol, to devices and so on. There are mechanisms for having discovery of devices that are near, and there's also a REST API to expose the functionality of the solution itself. Second block is all around automation, which is really the smart part of a smart home. And on automation, it allows you to define what should actually trigger something, what could happen, and to combine that very easily, also through scripting, into working use cases. Third part is user interface, which means that there's really a way to describe declarative for your UIs, to say what kind of information you want there, how it should be structured, but in a way that it's independent of the specific devices, and that you can have different user interface implementations on top of that. So for various smartphone platforms, web applications, and also specific UIs for some vertical solution that you might want to do. Last but not least, persistence, so all how to handle the data. The core events, they are just floating around, but you want to keep track of them, you want to filter them, you want to process them. So this is all the aspect about persisting that, and persisting also means that you can decide now to take part of that data and send that up to some cloud service for big data processing and so on. More from a runtime perspective, the tricky thing that Eclipse SmartHome tries to achieve is to really allow to be extensible from two ends. The top end is what you usually call the applications, which is one, the user interfaces, meaning you can monitor, you can control things. But more importantly, also the automation rules, because usually if you are asked to describe a use case or an application for a smart home, it will be more or less a piece of logic that you describe, which can be transformed into some rule that needs to be executed. So this is really the functional level, the application side of things, and the other side. That was the wrong computer. The other side is the physical world, so the connection to the real devices. And these are done through the so-called bindings, as I've mentioned. And now the good thing here is that really these two levels are decoupled from each other. So you can keep your existing user interface and add new kinds of devices that weren't known to the UI before that they could ever exist. But it's really brought to an abstraction level so that the UIs can deal with that, and that the devices can describe themselves good enough so that it's possible to work with them. And also the other way around, independent of what kind of UIs exist, you can just implement more or less your binding for a specific thing, and you don't have to care of what specifically has been done in a certain user interface. Now this is just a short example list of what bindings exist in OpenHub version 1. It's not even half of what is there. Just to give you an idea how eager the community is to build things there. So almost everything that you've heard about around smart home is covered by the OpenHub solution. So it's really fairly easy to get started. If you want to build some demonstrator or anything, you are most likely to find already the bits and pieces that you need. Okay, now let's have a bit closer look at how to implement such a binding. And I said, okay, you have to provide some kind of abstraction here, and we call the things internally, very easy. And things have channels which are more or less different functionalities, and that's the finer granular level where you actually do the matching then to the UI. So it's the channels, it's the functionality. We're not trying to say this is a washing machine and it has to have these 5 features, but you just list the features and they are then the relevant part. A bit more complex, you can do the setup as well. There's a subtype of things called a bridge, which is a special device which you need in order to get access to other devices, a kind of second gateway in between, for example, or something else. And you can also group such channels together if you have them recurring in one single device, like a multi-level actuator, for example. Okay. Enough of the talking. I also want to show you some blinking lights. Let me see, is that working? Yeah, good. So I have an OpenHub 2 installation in my IDE here in Eclipse. It's fairly small, but at the time then when you should read something, I'll try to magnify it. Is that size okay? Should be okay. Good. So in here, let me just start up the runtime. And move over to the browser. So this is one user interface that supports administration functionality. And let me scale that over here. We can see in the configuration that here I have installed two bindings, one for LiveX, which is this LED bulb here. It's a Wi-Fi enabled bulb, so it's directly hooked up already to my router, to the network here, and just sits here waiting. It's already powered on, but the light powered off. The other binding is Philips Hue, that you will probably know, also LED color lighting system. So two color bulbs, two different vendors, two different technologies, and I'm moving too much. And here on the things we also already see we have the LiveX bulb listed here. We have the Philips Hue bridge itself, because that is based on Zigbee, and it comes with a Zigbee gateway to IP. So OpenHub itself connects through our IP directly to this gateway. But this is then such a bridge device, and the bloom, which is the small one there, is then the LED light itself. And here we can see on the control panel, so we have exactly the same kind of widget, the same UI, and we are able to control both of the bulbs directly. I can't see the bloom here. Yeah, that's working as well. Very good. So why they turned on by themselves is that one here, right? So we can also have them operating directly simultaneously, as you see. Fairly fancy stuff. Dimming up and down and turning on and off. Well, that's just for toying around here, but it's a nice toy, I can tell you. Okay, so just to have two examples here, but one thing to show is how easy it is to get started with your own binding. For this I have to magnify that. This is a folder which is just a GitHub checkout of the project here. In here we can go to add-ons folder, bindings. If we look here, there are a couple of bindings already, Sonos, Max, Network, Astro, Freebox, whatever. And we see there's a script create binding skeleton. If we call that, it asks us to provide a parameter, binding ID in camel case. Okay, let's call it cool stuff. We run that script. And it's simply a Maven archetype that creates us a skeleton. I'm putting my author and confirm. Okay, so it has created it. And we see, yeah, there in the middle is our binding.coolstuff. So let's go and import that into our IDE. Import existing project from our folder. So we see there is one new one. Let's import it. It directly compiles, and one important folder is the Eclipse SmartHome int folder in here, where you can describe some kind of metadata. First about your binding, more or less just giving it a name, description, author, not much more than that inside. But you can also describe your things that your binding can handle. And in here I have to magnify that again, I guess. So there's a thing type sample, which let's just call that cool thing, and channel types. So one channel defined for a channel type, where we have to define what kind of channel it is. Let's say it's a simple switch. We can give it a label. Get going. Okay, that's in here. Besides the metadata, there are 3 classes generated. So first one is a constant class. There's really just constants that you want to refer to from your Java code, and that are also existing in the XMLs. They are in here. There is a handler factory that is more or less generated. You don't really have to deal with that in detail. And the most important class is the cool stuff handler, because this is the one that really does the work in the end. So the whole framework takes care that this handler is initiated once one of your things is used. And there's the handle command method, where you get a channel unique ID passed into and a command, and you can now internally in this method implement whatever kind of Java logic you need to interact with your device, to speak a certain API, to do a certain protocol, and so on. So this is really all there is to get a quick start on that. We can now go here and add that to our launch configuration and relaunch the runtime. Okay, once this is there, we can check on the bindings, and we see, okay, now our cool stuff binding is listed here as well. What kind of things it supports, it's listed. And we can now say we're adding a new thing. It can't be automatically discovered because we didn't implement anything for that, but we can manually define one of this type. That's a bug in the UI. We can give it a name and store it. Now it's added as a new thing, and in here we see it's now listed. It's available to the system. It has the channel get going that we defined, and all of this can now be directly used within rules, within UIs, and yeah, all your own code can be directly tested and used. Okay, so much about the demo, and this is what I brought with me for tomorrow for the workshop. If you want to play with a bit more devices than just what I brought here and showed. And don't worry, none of that is explosive. The Frankfurt Airport security has done thoroughly tests on that. So yeah, feel invited to join the workshop on OpenHub Eclipse SmartHome tomorrow, and I bet we'll have a lot of fun of integrating all these different things and pieces together. And all of you are also invited to bring your own kinds of devices. So we've seen how easy and quick it is to start trying to integrate something new. So I would be very interested to see what don't we have covered yet, what might be nice to integrate here as well. So that was it. Thank you very much. Any questions?
Question? For the registry service, do you have in mind to put some real server around, behind the registry, or do you have to redo the registry every time, or the discovery? when you start your application, you have to discover your devices. So one way to discover is either to connect to a registry server to get the list of devices that are actually connected, so that you can get it immediately, or you have to ping, or
Okay, no, it has a registry of devices itself built in. So there is a thing registry, that's the name of it. And it keeps them in a database, really. And the discovery only works then for setting up and for adding new things. And it's also designed in a way that the user actually has to decide that he wants to include something. So the discovery first puts the stuff into a so-called inbox. And the user can then say, okay, I want to allow these devices to work on my system. Any more?
Yes, I have a question about the domain model in the core. Because you say that a thing can be anything. Is there any effort to try to standardize on some domain model or something like that?
Yes, there are many efforts out in the world, and that's the reason why I didn't try to start yet another effort on that. So the domain model is really trying to be kept rather primitive, or using many primitive types, and then rather having some additional meta information that is required for UIs to render widgets nicely and stuff like that. But I'm more or less waiting for other standardization authorities to come up with some good descriptions and some commonly accepted descriptions in the industry of devices, and I'm waiting for that and would like to introduce that and make that possible to use them, but not trying to do it my own.
You have an event abstraction around the domain model, and do you use the events to wrap a camera stream, for instance, when you have a multimedia stream?
Good question. Yeah, a stream is not really an event, so it's really something very different from point of architecture. There is also support in OpenHub for camera streams, but this is really not on all these item and event infrastructure, but it's a different infrastructure aside. But also here I'm trying to keep things fairly simple and not wanting to reinvent something like the LNA or whatever. And what is possible through the events and items is still pictures. So if you have a camera, you can take a snapshot picture and send that as an event. So that much is supported there.
And for the command part, do you use the event? So you have an asynchronous command, or is it something different? When you want to turn on and off the lights, is it done through events?
That's all events and all asynchronous, yes. So it's actually you're sending a command there, and it's sending then a status update back asynchronously.
Thanks.
Okay, I think time's up. And over to André. Thanks again.